So today we are starting Unit 5 and we're going to start talking about triangles. Now, the whole point in this unit is to eventually get to where we prove that triangles are congruent and use the fact that triangles are congruent to prove other things congruent. But first we got to learn a lot of properties of triangles, okay? So today we're going to focus on some different angle measures in triangles and things like that. So let's start with talking about the different ways to classify triangles. You can classify triangles two ways, either by the lengths of their sides or by the measures of their angles. Okay, so there's three different ways you can classify triangles by their sides. If all sides are different lengths, we call that a scalene triangle. If all the lengths are different lengths, we call it a scalene triangle. All right, if we have a triangle where two lengths are the same, two out of the three are the same, that is going to be called an isosceles triangle. Okay, so that's two congruent sides and a third side that is not congruent to the other two. So that's called an isosceles triangle. And if they're all three congruent sides, that's called equilateral. If all three sides are the same length, it is called equilateral. All right. Now we can also classify. It did not scroll. Oh, it's because I have y'all frozen. No wonder. We can also classify triangles by their angles. All right. So there's four ways we can classify triangles by their angles. The first one is an acute triangle. An acute triangle have all angles are less than 90 degrees. If all three angles are less than 90 degrees, they're all acute angles, and it's an acute triangle. Okay? What does a right triangle have? One right angle. Is it possible for a right triangle to have more than one right angle? No, because then the interior angles of a triangle have to add to make 180, and then there's no room for a third angle, right? So there can only be one right angle. An obtuse triangle has one obtuse angle. Again, is it possible to have two obtuse angles in a triangle? No, because that would exceed more than 180 degrees, right? All right, and then three congruent angles makes equiangular. Notice there's no L right there. It's not equiangular. It's equiangular. It's hard to say. So equilateral has three congruent sides. Equiangular has three congruent angles. All right, bonus question for the day. If it's equiangular, what are the exact measures of the triangle angles? They got to be 60, right? For it to be equiangular, they all have to be the same amount, which would have to be 60 degrees. Because all the interiors have to add to be 180. 180 divided by 3 is 60 degrees, right? Okay. So, y'all don't have to write this down, but y'all just tell me. Classify a triangle with side lengths of 5 centimeters, 7 centimeters, and 9 centimeters. What do you think? Bless you. Well, first of all, that's side lengths, isn't it? So it's one of the top three up there. So what would it be? Scalene. They're all different side lengths. So that is a scalene triangle. Any questions about that? This next one. A triangle with angle measures 60 degrees, 60 degrees, and 60 degrees. Equiangular. If it's same sides, did I spell that right? If it's same side lengths, it's equilateral. If it's same angle measures, it's equiangular. So any questions about those? Okay. All right. There are different angles in a triangle. Y'all need to write these down. I'm getting a copy of this. Write this down. There are two types of angles when you're talking about triangles. No, that's not. Let's talk about this. If you do not put the line in the equal sign, technically that's interior angles and exterior angles. And I'll let you write those down. And then I'll scroll and show you the picture in a little bit. That makes sense? And we all know that 2 is not equal 0, so make sure you put the lines to the equal sign. And then we're going to have x plus 1 equals 0, and x plus 4. If you can read my handwriting. Interior angles are the angles on the inside of a triangle. Exterior means outside, right? So that the angle's formed outside a triangle if you extend the sides.
I'm not going to do the second question. Very good. Next equals negative. If we were graphing this, these two solutions are where the graph crosses the x-axis. Hence the name x-intercept that we talked about earlier. Very good. All right. So this is kind of similar to what we did yesterday. We just have a DCF or a trinomial other than that. Any questions on this first problem? All right. Number two. We're going to number two.
Can I scroll a little bit so y'all can see the picture? There you go.
Raise your hand if you think step one is complete.
And notice I color coded my definitions with those angles. The green ones are the exterior angles and the blue ones are the interior angles.
So again, I ask, raise your hand if you think step one is complete. All right, a little bit better. The thing that didn't get a participation grade for that last question. All right, so step one is complete. Step two is this complete? No, it is not completely accurate. What do we always try first? Yeah, what is the DCF? 3. Right? And what's right after the 3? Very good. Very good.
We good? Interior angles, the angles inside the triangle. So those are my blue ones on my picture. And the exterior angles, if you extend the lines of the sides of the triangle, then those are the angles formed outside of the triangle. Bless you. Bless you. Notice that these two form a linear pair. Y'all see that? And these two form a linear pair. What do these two form? They're vertical angles. Interesting. Interesting. Can I scroll? Okay. Triangle sum theorem. This one is on your handout. It's the very top one. So instead of writing that, you can highlight it. Triangle sum theorem. And y'all pretty much already know this because we kind of went with this a little bit when we was talking about the classifications of triangles. Triangle sum theorem basically says the sum of the interior angles of a triangle is 180 degrees. That means I add all the angles inside any triangle, they should add to be exactly 180 degrees. Okay? Always, always. All right. The next theorem on your handout is this one. It's the exterior angle theorem. So you can highlight this one as well. Exterior angle theorem. So we already said that the exterior angle is an angle formed if you extend the side of a triangle, right? So here's a picture of a triangle, and then this side is extended. So this angle 1 right here is an exterior angle. So the exterior angle theorem says the measure of an exterior angle is equal to the sum of the measure of the two non-adjacent. What is non-adjacent?
Not next to.
Not next to. Otherwise known as not touching. Okay? All right? So it's equal to the sum of the two that are not touching that angle. See, angle 1 right here is touching angle C, right? Y'all see that one? So the non-adjacent ones are A and B. So if you want to find the measure of angle 1, you would add A and B together. Okay? The measure of angle 1 out here will be the measure of A plus the measure of angle B. Okay? So now that we know that, we can find lots of things about angle measures. Here's an example. Copy that down, please. You really don't need that point M out there. It's just there. This is angle L, angle J, and angle K. Angle L is 70 degrees. Angle J is X degrees. And the exterior angle is 2X minus 5.
Don't do number 4, do number 3. Only do number 3. Okay. Start at 4.
So it says to find the measure of angle JKM, which is the exterior angle, correct? Correct. Well, before I find that measure, I got to find X, don't we? Right? Y'all agree? Yeah. I got to know what X is before I can know that measure. So what do you think I can do to set up an equation so that I can find X? Well, I can use the exterior angle theorem, right? Yeah. Right? So you use the two angles that are not touching that angle and add them together and set them equal to the exterior angle, right? So I can say X plus 70 equals the exterior angle, which is 2X minus 5. Y'all see that? You add together the two non-adjacent angles, set it equal to the exterior angle. All right, how do I solve that for X? Yeah, that's probably the easiest move. So 70 equals X minus 5. Add 5, and X equals what? X equals 75 degrees. So you can you've got two ways you can find that measure of that angle. Somebody tell me one way I could do it. 70 and 75. Yes, because I know this is 75, right? Or I can plug it in also, right? 2 times 75 minus 5. Either way, that should be 150 minus 5, 145. And that also is 145 degrees, isn't it? Yeah. So 145 degrees. And again, be sure when you find an angle measure, you put a degree symbol. Okay with that? Pretty simple concept. You add the two angles that don't touch the exterior angles and set it equal to the measure of the exterior angle. Okay? Any questions about that one? Okay. Same kind of problem. Reverse setup. Y'all want to do it without drawing the picture? I think y'all can, right? So how would I set this up to find the measure of angle DEF? First, you got to find what? Got to find X. How do we set it up so we can find X? Very good. 80 plus X equals 3X plus 6. You add the two non-adjacent interior angles and set it equal to the exterior angle. Is everybody okay with that? Everybody okay with setup? All right, how do we solve that for X? Subtract X on both sides. So 80 equals 2X plus 6. Then what? So that's 74 equals 2X. Divide by 2. 35. 6, 37. What is it? 37 equals X. Am I done? No, I got to find the measure of angle DEF. How could I do that? Yeah, I can put that there for X and add 37 plus 80. Or I can say 3 times 37, I don't know why that erased itself, plus 6, right? What do we get? 117 degrees. And you can do it both ways and check yourself, right? What do you think? Easy or hard? Okay, good. Oops. This one is a you try. Oh, me. Let's talk about strategy. You're finding the measure of angle 1. So what will you have to do first? Find X. And then there's a couple of things you could do to find the measure of angle 1, couldn't you? Right? So after you get X, first of all, you could do triangle sum theorem and do this plus this and subtract from 180 to get this, right? Right? Or you can get this and subtract from 180 because those make a linear pair. Does that make sense? That makes sense? All right, y'all go for it.
Now it's completely backwards. Yes, it is. So we said each factor equals to 0 and solve each equation. So we're gonna have 2x plus 5 equals 0, and x minus 1 equals 0. 2x plus 5 equals 0.
Find x first, and then you got options. That's not 1 degree. That's just the name of that angle, okay?
2x equals negative 5. Michael, what am I gonna do next? Very good. Divide by 2 on both sides, and x equals negative 5. Alright, x minus 1 equals 0. Class, what do I do to solve that equation? Add 1. Very good. X equals. So that's not too bad, is it? Not really any new information. We learned about solving those factors yesterday, and now we're just applying it to living what makes not meaning. Right? Any questions on it? Are we good on the check? Number 5. 8x squared minus 22x plus 5 equals 0. So step 1, is the equation set equal to 0? Yes, it is. Step 2, is it completely backwards? No, it's not. Alright, what's the GCF? 1. We have 3 terms, so we make a table. 2 factors add to equal negative 22 and multiply to equal 40.
All right, check them with each other. Remember, you're finding the measure of angle 1, not just x. Yeah, am I right?
Do you understand what both factors have to change? Plus 5 equals 0. I go back to 4 terms. There's a first 2, there's a sign, there's a lag. Forget what the GCF is.
Ooh.
Factor up 2x, 0.
Okay, so how did you set it up first to find x, y'all? The exterior angle theorem, right? So did y'all say add together 3x and 40 and set it equal to 5x minus 10? Okay, so how do I solve that for x? Subtract 3x. I froze again? It extra froze it. Okay. And then 40 equals 2x minus 10. And then you add 10 to both sides, so 50 equals 2x. Divide by 2, and what did you get? 25 equals x. So that's easy to find this angle up here. 3 times x is what? 75 degrees. Did y'all get that? So you got options. You could add these together and subtract from 180 to do that and do triangle sum, right? You could add these together and put it right here, and then you can still subtract from 180 because that's a linear pair. Y'all agree? So either way, you're going to add those together and subtract from 180, no matter how you think about it, right? So what is 40 plus 75? So measure of angle 1 is going to be 180 minus 115, right? And what is 180 minus 115? 65 degrees. Raise your hand if you got 65 degrees for the measure of angle 1. Are there any questions? Okay. Do y'all understand how y'all could have thought about that both ways? Either way is fine. Okay. Good job. Here's a definition. You don't have to write it down. Well, you might want to, because you'll see the word corollary a lot. I can't even say it. Corollary. Corollary. My John wouldn't be able to see it because he can't say his L's and R's. He doesn't have very good speech. He'd say cool Willie. Cool Willie. Right away. All right. So a corollary to a theorem is basically another statement based off of that theorem. So a corollary to a theorem is a statement that's like a theorem based off of another theorem. Because this phenomenon happens, then we can say this is going to be the case. So a corollary is just a statement based off of a theorem. Okay? So on your handout, find the corollary to the triangle sum theorem. It's the third one down, isn't it? Corollary to the triangle sum theorem. So you don't have to write that down because it's right there. And that's a terrible triangle I drew. Okay? So a corollary to the triangle sum theorem, well, the triangle sum theorem says all the interior angles of a triangle add to be what? 180. So a corollary to this theorem says for a right triangle, we got 190-degree angle, right? Right? So what's left for the other two angles is 90 degrees to split between them, right? So this corollary to the triangle sum theorem says that if you have a right triangle, then the acute angles in the right triangle must add to be 90 degrees. Okay? All three of them add to be 180, but since you already got a 90-degree angle, there's 90 degrees left to split between angle A and angle B. Does that make sense? That makes sense? Okay. So this is a corollary because it's based off of the triangle sum theorem. Oh yeah, I think we got word problem. Oh yeah. Y'all don't have to write the paragraph. Just draw the little right triangle. Yeah, y'all like my stairs? You don't want me building your house, that's for sure.
Is there a reason there's stairs there?
A staircase forms a right triangle. It's just a visual. It's just a visual. Okay. I'm gonna make that triangle a little bigger so I can write inside it. So y'all give me a second. Don't laugh at me. Whoa. Isn't that so cool? All right, so just draw the right triangle, be fine. If you want to draw the stairs and be cutesy, you can. It's your notes. Decorate them how you want to. This is good carpentry examples, right? Except for, look at that. That is not me. That's not a good staircase at all. Okay. Don't let me build your house. Have y'all ever seen a staircase like just the structure of it without the sheetrock and everything on it? You ever seen like a wooden staircase? They're pretty cool. Pretty cool. Right. Okay. So yeah, so there's usually like a beam that goes right there, and then all of them kind of attach to it, and these run perpendicular or parallel to the floor, and these run perpendicular, right? And they got to attach to that beam, so I didn't attach mine to the beam. Oh well. All right. So a staircase forms a right triangle. The measures of one acute angle in the triangle is twice the measure of another. So what you're going to do, so that means one angle measure is 2 times as big as the other, right? Twice means 2 times, right? Right? So if this angle is X degrees, what's the other one then? 2X. Y'all see that? Okay? So if one's twice the angle measure of the other, if one's X, the other one's 2X. So just assign a variable. All right? Well, find the measure of each acute angle. Well, that corollary to the triangle sum theorem said if it's a right triangle, then the 2 acute ones have to add to be what? 90. Now you could say 2x plus x plus 90 equals 180, but that corollary shortens the step for you, right? Makes you have littler numbers to deal with and less steps in your equation. So all we have to do is say x plus 2x equals 90. X plus 2. I keep hitting the button. plus 2x equals 90. Combine like terms. What's x plus 2x? 3x equals 90. Divide by 3 and x equals how much? 30 degrees. So one acute angle is 30 degrees. The other acute angle is what? 60. So that would be a 30-degree angle and a 60-degree angle. And is 30 plus 60 plus 90 equal 180? Yes. Y'all see how I did that? Add them up, set them equal to 90 if they're in a right triangle. Okay? All right. Can I scroll? We good? All right. Y'all find those acute angles, please. One is 2x and one is x plus 6. 2x and x plus 6. You don't have to draw the triangle, just find both angle measures.
You are parentheses now. Okay, so we write 2 binomial factors, 2x plus 3 and 2x plus 3. Can't forget equals 0. Now, did you notice anything here? It's the same. So what we have been doing, we have been rewriting this as 2x plus 3 quantity squared, yes? Now, we're not going to solve it at this equation, and here's why. We're going to learn how to solve by square root next. Okay, we haven't learned that yet. So what we're actually going to do, we're going to leave our work exactly as it is, but we're going to use this step right here in order to solve our equation. Does that make sense? It's the same thing. What do you think?
Find both angle measures. And they should add together to make 90.
Yes? So
That's a quick check.
2x plus 3.
So how do I set up my equation? And then I do like terms. So 3x plus 6 equals 90. Subtract 6. 3x equals 84. Divided by 3. What's 84 divided by 3? 28. All right, but that's not one of my angle measures, is it? Nope. I've got a 28 times 2 and a 28 plus 6. So what is 28 times 2? 2 times 28. So one of them is 56 degrees. So I have a choice here. I can plug in here or I can just subtract from 90, couldn't I? Right? Right? I don't trust myself, so I'm going to do 28 plus 6, which is what? 34. And then I like to check them. Do those two add to get 90? Yes. There we go. We good? Easy? Not bad? We've done worse, haven't we? Yeah. More examples. Now, this is just what you're going to see on your practice. These are two different problems. Can y'all just hang with me? I think y'all can just watch me and participate. Okay, let me just get that whole picture up here. All right. Find the missing angles. So we got to find angle 1, angle 2, and angle 3. Well, let's find angle 1. It don't matter the order you find them. Let's just find them. How can we find the measure of angle 1? Add 61 and 68. Subtract from 180. Y'all do that with me. 61 plus 68. And then 180 minus 129. What are y'all getting? Come on, everybody participate. Grab a calculator. 51 degrees. And then you can check that, right? Right? Okay. I think I'm going to need to know angle 2 before I can get angle 3. But look at angle 2. What do you see there? They're vertical angles. So what's the measure of angle 2? 61 degrees. So how could we get angle 3? Or, right, since it's a right triangle, these two have to make 90, right? So what's 90 minus 61? 29. So okay with everybody? So you'll have some of these on your practice, okay? Check out this. All right, the ones I think I can get pretty quick, I think angle 1 will be the last one I can get. Well, maybe 4 and 5. All right, first I'm seeing right here, this is sticking out to me, angle 3 and 73 degrees. What do those two angles make? They're a linear pair, right? So how do I find angle 3? So y'all do it with me. 180 minus 73 is how much? 107 degrees. Y'all okay with that? Oh, okay. So now, didn't say these were parallel lines, did it? Do I assume parallel? Yeah. They don't tell me they are. Is there something else I could do? I bet I could do, we'll shoot for. I'm thinking. Hang on. I can do this. Wait, I just lost it. Sugarfoot. Y'all look, what do y'all say we could do? I'm trying not to assume parallel, but I think I'm going to have to. You think we're going to have to? I don't want to because nothing tells me it's parallel. And I don't remember where this problem come from. What do y'all think? Are we going to have to assume parallel? Dang it, I hate assuming. All right, so if that's parallel, then this one is going to be 180. And these are alternate interior, so this would be 73, wouldn't it? Right? And let's see if that works out. So then I could, all three of those, angle 2 with angle 1, 2, and 49 degrees equals 180, right? So 73 plus 49 is 122. 180 minus 122 is what for angle 2? 58? And then I can get angle 5 and angle 4 from there, couldn't I? Right?
But wouldn't angle 4 also be an alternate interior?
Well, that would be our way to check if these were parallel or not, wouldn't it? And it's not working out. So we can't assume parallel. You see what I'm saying? Those don't be the same because those don't add to be. Or do they? 73 plus 58. No. Yeah, yeah, it is. Okay. Sorry, that is 49. So yeah, it works out. So we should have assumed parallel. So how do we get angle 5? 180. And that's what, 131? Oh, we did it. So we did have to assume parallel. So it'd have been nice if they had put another like set of arrows on it, wouldn't it? Okay. That'll help me for next block. Thank you guys. Good thing y'all are honors, right? All right. How would we do a problem like this? Y'all can just watch, but how would I do it?
So don't add them all up to equal 180.
All right. Y'all do it with me then. I'm going to say 9x plus 3 plus 5x minus 2 plus 11x minus 21 equals 180, right? Y'all see what I'm doing? They all add to make 180. So I'm going to combine my like terms. 9x plus, you won't let me mark, plus 5x is 14x plus 11x is 25x. And then 3 minus 2 is 1 minus 21 is minus 20. 1 minus 21. That's what I thought. Equals 180. And then add 20, 25x equals 200. So x equals 8. Okay. And then I plug them all in. 9 times 8 is 72 plus 3 is 75, right? 5 times 8 is 40 minus 2 is 38. And I can add those together and subtract. Or it's 88 minus 21. I'm getting 67. Is that right? And then I'm going to check them and make sure they add to make 180 because I'm a perfectionist. And they do. Y'all see how I did that? Okay. Now, how would I set this one up? We've done these.
Add K and J.
And set it equal to the exterior angle, right? So 7x minus 32 plus 5x minus 27 equals 9x minus 8. Combined like terms, 12x minus 59 equals 9x minus 8. I'm going to subtract 9x. So 3x minus 59 equals negative 8. Add 59. What do we get there? That's what I thought. It ends in a 7. And then we can plug in from there. Right? Right? Okay, this is what I was trying to get to. All right, so I drew a triangle. It says if in triangle ABC, the measure of angle 7 is 6 less than 7 times x. 6 less than 7 times x. So how do we write that in algebra terms? Yes, 7x minus 6 for angle A. Is everybody okay with that? Okay. And angle B is 5 less than 3 times x. So what do I write for angle B? 3x minus 5. Y'all see what I'm doing here? My 5 looks stupid, but y'all can guess. And C is 5 less than 4 times x. So what is that? 4x minus 5. And then together they make what? 180. So 7x minus 6 plus 3x minus 5 plus 4x minus 5 equals 180. And you'd solve from there. Is that okay with everybody? So draw the triangle. If they don't give it to you, and fill in the angles. It helps, trust me. All right. This one, same thing, I'm pretty sure. Measure of angle L is 13 more than the measure of angle K. So if it says one more than the other, then I'm going to call that other one just X. Does that make sense? So then angle L is 13 more than X, which is, and that's L, X plus 13. And then J is 7 more than 6 times X. So that's 6X plus 7, right? And then you add those together, so that'll make 180 as well. That sound good? Okay. So if I rush through that, I'm sorry. Y'all can come see me if you see it on your practice and you need help with it. I just wanted y'all to see an example of everything on the practice and have time to work on your practice. So that is technically the end of notes for today. I'm making sure. Have a good day.